So we have y is equal to 3x squared over x plus 1. So x equals 0 means y equals 0, and y can only be 0 when x is 0, and therefore we can see that the origin is on the graph. We have a vertical asymptote when x is negative 1. Now, it's an improper fraction, so it's a good idea to divide. So we have x plus 1, and then we have 3x squared plus 0x plus 0. So x to get 3x squared, we'd multiply by 3x, and that gives me 3x squared, and then 3x times the positive 1, plus 3x, and we'll subtract, and that's negative 3x, and bring down the 0. X to get negative 3x is negative 3. So, negative 3x, take away 3, subtract, and we get 3. So we can write this as y is equal to 3x minus 3 plus 3 over x plus 1. And that identifies an oblique asymptote, which would be y is 3x minus 3. Now the reason that's an oblique asymptote is if we think about x becoming very, very large, this part will become very, very small. And therefore we're left with 3x minus 3. So it's going to tend to 3x minus 3 when x is very, very large, either positive or negative. So let's have a look at turning points. So u is 3x squared, v is x plus 1, then du dx is equal to 6x, dv dx is equal to 1. So dy dx is going to be v du dx, so that's 6x x plus 1, take away u dv dx, which is just 3x squared, all over x plus 1 all squared. So that's going to be 6x squared plus 6x minus 3x squared over x plus 1 all squared. So that's going to give me 3x squared plus 6x over x plus 1 all squared, which is 3x x plus 2 over x plus 1 all squared. So dy dx is going to be 0 when x is equal to 0 or negative 2. So we're going to have a turning point at 0, and substituting that in here, 0, 0. And if x is negative 2, that's going to be 3 times 4, 12 over negative 1. So at negative 2, negative 12. We probably don't need to look for the type because it should become obvious when we start to draw the graph. Let's just look at regions. We have x plus 1 and we have x squared. X squared never changes sign. So we'll look to the left of negative 1 and to the right of negative 1. So this one is negative, and this of course is positive. So y will be negative here, and these are both positive, so y will be positive here. So let's try to do a sketch of this. So here are our axes, and then we've got a vertical asymptote x equals negative 1, and we've got an oblique asymptote, y is equal to 3x minus 3. We know that it goes through 0, 0. We also know that's a turning point. And from here, this side of the asymptote, the curve is always above the axis. So there's only really one thing it can do, which is come down from the vertical asymptote, have the turning point here at the origin, and then go off along the oblique asymptote. To the left here, we know that it's negative y, so it must always be below the axis. Negative 2, negative 12, there's a turning point. So there's only one thing it can do here, which is come up and then along. So that's what it's going to look like. And here is an accurate plot. And we can see the minimum turning point here and the maximum turning point here, and we can see the behavior as it goes along the asymptotes.